Taking part in this press conference, we have John Burrows, Professor of Physics and Chemistry of the Atmosphere at the University of Bremen in Germany. Tony Brown is a Professor of Physical Geography at the University of Southampton in the UK. Ronald Poppel, who is a Senior Lecturer at the Geomorphological Systems and Risk Research at the University of Vienna in Austria. And Jan Zalacevic, Senior Lecturer in Paleobiology at the University of Lancaster in the UK. And I'll just hand over to our speakers, and then we'll open the floor for questions.
So thank you very much, and I'd like to thank EGU and the press team for inviting us, me and all of us, to talk. I'm going to begin by talking about observing the Anthropocene from space, but before we get there, this is the type of instrument that we do use for this. These are satellites, and this has been a European-led breakthrough basically of the last 20 years. Okay, and I'll come back to that and what we need in the future. But the basic problem is Homo sapiens appeared 200,000 years ago. Up to the Neolithic Revolution, there weren't very many of us. Up to the Industrial Revolution, there were about 1 billion on biofuel, a little bit of coal, etc. Since then, we're now at 7 billion, and this is essentially driven by fossil fuel combustion. This is having a massive and land use change, okay, and we're expecting to get up to 10 billion with 75% of us living in urban areas by about 2050. The question is, we've moved from basically a system which was dominated by, you might think that we're like humanity is riding as a passenger on a ship, and now we're driving it with our emissions. Okay, so the Earth's changing, and this concept of Anthropocene, originally from Sturmer, but popularized by Crutzen. So we've entered a new epoch. We're having dramatic changes of emissions from the population through its industry and land use change. This impacts on global transport and transformation of chemical species, climate change. We've seen the global destruction of ozone, which through the Montreal Protocol we're getting on top of. But basically, we can't manage. The future hope is that we can manage it and attain sustainable development. And to do that, we need an adequate measurement system. Now, what are we actually seeing? Okay, well, we're basically able to now see air pollution, for example, from space. I'm going to focus on urban conglomerations, sort of megacities. Please note that WHO pointed out that 7 million people, premature deaths are now occurring, and of course we're having an impact on the biosphere. We've had a dramatic 100 years and a particularly dramatic last 50 years. And this type of picture of smog is now, that's daytime in basically China, and that's sort of a very typical phenomenon. But if you remember, only a month ago, we had very unusual pollution here in Europe, which is a mixture of modification of probably desert dust coupled with local pollution. So what can we see from space? And this is the way you do it. Now, this is the type of picture we typically see, and what you immediately see is the pollution centers. NO2 is one of the precursors of ozone. It's an oxide of nitrogen dioxide. NO and NO2 are called NOx, and they're the key species which lead to ozone formation. They also form nitric acid, which goes on to aerosols. Okay, so another thing you can see easily is biomass burning. Another thing is outflow. Okay, if you look at the trends on these things, you see massive trends, and this is now the current database for China. If we just take China and Europe, okay, these are the type of things we can see. You can have these pictures afterwards. India, for example, we're seeing huge increases in the last decade, up to 10% a year in certain cities. This is now the situation in China, just brought up to date. We may be seeing a flattening. In Europe, there's a kind of leveling off. On SO2, I'll just jump to the same type of pictures. We see the pollution. This is a situation that in SO2, pollution measures did work, but now we're seeing an increase again. Okay, on aerosol, similar sort of picture. If we look at China, basically Europe cleaning up through legislation, change of traffic fleet, this sort of thing. China, very large. I can talk about the details. Okay, just to summarize, with this first generation of satellite, we've seen huge increases in pollutants in urban conglomerations. In Europe, we've seen, fortunately, and Europe and North America, some improvement, but now it's flattening off. This has been a pioneering age, but we need a much better measurement system in order to meet the needs. Okay, I'm finished. Thank you very much. I think you need to now escape and let's see. Oh no, sorry. No. That was right.
Thank you very much. I want to look at the question as to whether we can see the Anthropocene in the rock record. Technically, I suppose, formally, to be a new geological epoch, you need to be able to observe it in the rock record. And that's where studying the last 10,000 years comes in, the period that we, of course, at the moment refer to as the Holocene. And if you want to identify, for example, boundaries in the rock record, you need to show that they are both laterally extensive within sedimentary basins, or indeed that they are extensive erosional hiatuses, broad areas of erosion across large areas. And you also have to do something which is unusual for geologists, which is you have to predict that they would remain in the future, which after all is not really what geologists generally do. So I've therefore approached this by saying, well, if we look at sedimentary sequences, do we see a hiatus which is both laterally extensive, that we can relate to human activity, and that we think would persist into the future? So I've taken, we can do this at a variety of scales. So we've got a basin that we've been looking at in the United Kingdom, which is one of our largest basin, the River Severn and Wye put together. It comes to 155,000 square kilometres. And then to use smaller basins within it and see whether we can move from the small scale, the small catchment, which we would expect to be affected by human activity, such particularly soil erosion related to deforestation and agriculture, and then see whether it applies, whether we can trace that through to a larger catchment and then a larger catchment again. And then eventually, of course, we'll move up to the scale, the continental scale, what's its distribution in relation to the pattern of the human forcing on a global scale. So if we look at this catchment here, this is the Severn Basin, the Severn Wye Basin. It covers a large chunk of central or western Britain, from the mountains of Wales down to the lowlands of the Severn Valley. And then within that, we've got a basin there called the Froome, which is basically an order of magnitude smaller. And then we've got another very small basin nested within this basin as well. So we can see, can we see this sedimentary boundary at these different scales? This is the catchment of the Froome, where we've used a combination of geophysics. We've also used radiocarbon dating and OSL dating, and I'll say a little bit about that. To date, the large sedimentary body that you see in the picture in the top right, which dwarfs the postgraduate there, who's not that short, it's about 5 meters of sedimentation in what is, by global standards, a very small catchment. And the importance is that some techniques have helped us look at sediment budgets, and the important change has been to move beyond radiocarbon. Radiocarbon is very limiting because you can't date inorganic sediments. However, with both OSL and now increasingly with cosmogenic isotopes, it's possible to get sedimentation rates through these large units. So what we then have at the bottom right is basically budget estimates. That's an estimate of the amount of erosion from the catchment computed from the rate of sedimentation, the area of sedimentation, and then making an allowance for the amount that will be leaving the catchment. That is itself slightly problematic, but therefore these estimates are nearly always minimum estimates of the erosion in a basin. And although I'm afraid the figures are rather small there, you'll see that the average over the Holocene is around about 50 tonnes per square kilometre per year. But in the last 2,000 years, and particularly the last 1,000 years, that can go up to about over 100 to even 150 tons per kilometre per year. And the very small basin produced many years ago when we first did a budget. In fact, the first sediment budget for a catchment in Britain is the small graph in the bottom left. But as you'll see, the figures are basically comparable, although the dating frequency was not as good. What that tells us is that basically we've had all of that sediment, or in fact it's about 80% of the sediment fill, is that very uniform material that you can see in the picture, and that is all post the last really 3,500 years. It's all produced after the deforestation of the catchment during the Bronze Age, particularly the late Neolithic and into the Bronze Age, and basically then a continual erosion and sediment transport due to tillage particularly, and it must therefore greatly exceed the soil production rate. We now have much better estimates of soil production rates, although there are still some problems here, and that is that these rates of perhaps 100 to 200, and in some catchments maybe as much as 500 tonnes per square kilometre per year, are an order of magnitude higher than any soil production rates that we can produce. So in theory, this is an unsustainable rate. We can come back to that if we want to ask questions about it. Oops. Now, if we scale this up, and I haven't put all the dating evidence here, but I thought it would be more useful in a way to show it sort of with a couple of graphics. If we go up to the main catchment, this is the River Severn, down towards upstream, obviously, of the tidal influence. But you can see this very, very large trench here that's put across the floodplain. And when they dug this very big trench for a civil engineering project and the archaeology in advance of this engineering, they revealed a landscape underneath it. And the figure beneath it, which has got all these colours on it, these are all elements of a buried landscape. It turns out to be very important archaeologically because it had basically a wood henge type structure, which is like Stonehenge but made out of wood. It also had trackways, and it was basically the first imprint of what was happening in that catchment down on the floodplain. But it was then completely covered by alluviation, again of about 5 metres, 4 to 5 metres in thickness. What we now can do is we can plot up the rates of sedimentation against some other indication of what's going on in the catchment. And the indication that I've got there on that diagram, which uses a combination of data from work by Mark Macklin and his group, and then also some work by archaeologists, what we've got there, the grey on that, the grey line, or the filled part of the diagram, is basically it's a proxy for agriculture. It's in fact the radiocarbon dates from carbonized cereals and also from pollen diagrams that indicate that there's cereal cultivation going on. What we now know from that is that in Britain, certainly, there are two phases. There's an early phase in the Neolithic, which wasn't very successful. It was probably very restricted spatially. The catchment was not altered dramatically, and we get very little sedimentary response from that. Then agriculture might even have almost disappeared in the British Isles for about 500 to 1,000 years in the late Neolithic. But then in the Bronze Age, around about 3,500 to 3,000 years ago, it really kicked off. And from that point on, the subcatchment was completely deforested and was under arable cultivation, which has gone on to the present time. Therefore, we can see this boundary at the scale of a large catchment in Britain, a medium-scale catchment, and a small catchment. And it's basically the same sedimentary boundary. And it's related to the transformation, total transformation of these catchments by agriculture, by with a relatively low global population, but of course a population which has increased dramatically due to the transformation from a hunting-gathering way of life to an agricultural way of life. And it is persistent in the sense that if we do a calculation, it would take a minimum of 30 to 35,000 years at the present rate of erosion of the sediments from the valley floor to remove this material. That means it's very unlikely to happen during one interglacial. That, by implication, means that it's likely to be a persistent feature of the rock record, and it's tied to agriculture. So, therefore, wherever we see the pattern of agriculture, we will probably see a transformation of basins, which will follow the global pattern of agricultural uptake. Okay. And therefore, it's either the early start of the Anthropocene, or you have to have it as a proto-Anthropocene. So that raises various questions about how we define the Anthropocene. Thank you.
Okay, first of all, thanks for having me here. Today I'm going to talk about the geomorphic legacy of dams, presenting some case study results from 2 small catchments which are located in Austria and the northeast of Austria. So as you will know, dams represent one of the most dominant and also one of the most earliest forms of human impact upon our fluvial systems, as these dams mainly reduce the downstream fluxes of water and sediments, so the downstream connectivity, which further induces significant geomorphic channel changes, mainly aggradation, sediment accumulation in the upstream areas, and channel degradation, channel bed and bank erosion in the downstream areas due to a lack of sediments, which in sum changes the longitudinal profile of our rivers. These geomorphic channel changes often have negative consequences for humans, maybe human infrastructure, roads, etc., which make the installation of protective measures like channel bed and bank protection measures necessary, or in recent times even dam removals necessary. Dam removals also have or induce geomorphic channel changes that often further require additional protection measures. So the geomorphic channel changes due to dam removal are mainly the erosion of the formerly accumulated sediments in the upstream areas and the degradation, so the accumulation of these sediments in the downstream areas. And if in the upstream areas there's some kind of building has taken place, these erosion processes in the upstream areas might again affect human infrastructure and again make these protective measures in terms of channel bed and bank protection measures necessary, like shown in this picture up here. A channel bed and bank protection which prevents the erosion of these formerly accumulated sediments in the upstream reaches. So our aim was to investigate the long-term effects of dams, so active dams, dam removals, and also of these channel protection measures on the channel morphology in 2 river systems in Austria. These 2 rather small catchments, rather small river systems located in the northeast of Austria. As you can see here is the so-called Fugnitz catchment and the Kaya catchment, which are impacted or have been impacted by a series of dams. So you can see here along these rivers there are multiple dams of which some are still active and of which many have been already have been removed. The greenish barriers down here. And mainly in the upstream reaches of the nowadays still active dams, in the downstream reaches of the nowadays still active dams, we have these channel bed and bank protection measures, as well as in the upstream reaches of these removed dams to prevent the erosion of the sediments in the former upstream reaches and the erosion of the sediments in the former impoundment areas. So you can see here a longitudinal profile of the Fugnitz River, and you can see some significant nick points along this longitudinal profile, which are mainly related to the presence of, on the one hand, active dams, like shown here, these black triangles, but also at locations of already removed dams. Here is a removed dam without channel protection, without channel bed and bank protection in the upstream reaches. And in this case, if there's no protection measure available or has been installed, a kind of balanced channel gradient reestablished. So the river channel slope becomes balanced again due to the erosion of the upstream sediments and accumulation in the downstream reaches. But if there are channel bed and bank protection measures installed within the system, they prevent the erosion of the formerly accumulated sediments in the upstream reaches and preserving these nick points along the longitudinal profile of these rivers. When looking at the cross-sectional profiles at locations of active dams without these channel protection measures, we have this typical incision in the downstream reaches. So channel bed erosion increasing the depth and the width of the channels in the downstream reaches. So we have an increase from the upstream to the downstream reaches due to active erosion going on there. In case of removed dams without channel protection, we have the opposite phenomenon, like I've shown you before, with upstream erosion and downstream accumulation. But in case of the presence of upstream protection measures, we have ongoing erosion processes in the downstream reaches, and still the preservation of the former state of the system, so preserving the sediments within our systems. This is also reflected in the shape of our landscapes, of course. As you can see here, we have 3 removed dams, then in the downstream reach, one dam which is still active, and along the channel reach of dam number 10, there is no channel bed and bank protection, so we have incision in the upstream areas, but at locations of the dams number 9 and number 8, we have these channel bed and bank protection measures preventing the reworking of these stored sediments within the former impoundment areas, and also preserving these nick points along the longitudinal profiles of our rivers. So the expected reverse change in fluvial geomorphology mainly, when the dams are removed, was severely hampered by the installation of these channel protection measures, so preventing channel recovery. So we have a long-term impact, we have long-term impacts and geomorphic effects, more or less, which I like to call the geomorphic legacy of dams, which still can be seen throughout our landscapes. This one?
Yes, that's the one. Thank you. Right. I'd just like to report very briefly on work of the Anthropocene Working Group, which is a group of the International Commission on Stratigraphy, which is looking at the potential for formalizing or not formalizing the Anthropocene as part of the geological timescale. So we're looking at this within the context of formal Earth history, which is stratigraphy. So I've got the, in effect, what we're doing when Paul Crutzen, who was a very great scientist, not a geologist, proposed this geological term with Eugene Sturmer at the beginning of this millennium, he was setting up a hypothesis that the people had changed the Earth surface system sufficiently to impact upon the geology, on a scale comparable with some of the epoch, period, and era-defining changes of the past. So go to the next one, please. And since 2009, following on the Stratigraphic Commission of the Geological Society of London, we reacted to the spread of the Anthropocene concept within the literature by examining it geologically. And this was in 2008. We published a paper in GSA Today, where we said, in our cautious stratigraphic way, this term, has some geological merit. It's not nonsense, but one could look at it more closely with a view to potentially formalizing it. We're very careful about changing the geological timescale. It's a backbone of geology, and we don't do it at all lightly. So since 2009, we were invited to form a working group by the ICS to look at this. Next slide, please. So we've published a volume of the Royal Society with various papers on different aspects of it. And this is a figure from a forthcoming book, again, a volume of the Geological Society of London, where, again, we're looking at it, the various kinds of stratigraphy, that is, events, processes, both human and natural, across time and space, which might help us understand, characterize, and define the Anthropocene. The questions being, is it geologically justified? And if so, how should one characterize it? At what level? Is it an age, an epoch, a period, an aeon, whatever? When should it begin? There's a question, and again, some of the talks here have referred to various human impacts at different times. And also, is it useful is it more use or more hindrance to actually create a formal term of the geological time scale for a term which is clearly out there and being used widely? So this is a diagram which just shows, the various natures of impacts both on land and in the sea, which have taken place at different scales at different times and places. We've had underground changes as well. A number of the human changes are quite novel. For instance, the level of species invasions across all oceans, all continents, is novel in geological history. The structures we build, of course, are entirely novel, which form, if you like, a stratum or trace fossil system, depending on how you prefer to interpret them. A lot of the materials we make are entirely novel as minerals and rocks, whether we think of metals, of new compounds, of concrete, of brick. And we're also having clearly an effect on the biosphere, that is, on the paleontology of the future. If we take the next slide, what we've been trying to do is to take these into different aspects. This summarizes the whole lot of different aspects of physical, chemical, biological changes to the Earth, really over the past several thousand years to the present, and even looking a little bit into the future. And as regards one question, when should the Anthropocene begin? This is something that we're currently working on. There are clearly effects going back thousands of years and centuries, as both Tony and Ronald have so clearly shown. And these tend to be modifications of the land surface rather than of the marine environment. And they're clearly diachronous, that is, they reflect human migration across the planet, and they cut time boundaries. And that makes them, they're very important in terms of Earth history, but they make them less convenient for setting up a geological time boundary, which has to be synchronous. It has to be, as far as we make it, a synchronous marker. Then we have Paul Crutzon's original suggestion, which is the beginning of the Industrial Revolution, about the grey layers there about 200 years ago. Again, industrialization, growth of humans above a billion, great increase in fossil fuel use and so on. That again is rather sharper. It's an increase in, if you like, perturbation of the Earth system in many ways, increase in scale, but also it's time transgressive. The revolution, the Industrial Revolution, started in Britain, moved across to Europe, moved across to North America, and so on. And then the nearest to us, about in the mid-20th century, there is again an increase in scale. That is, most of the fossil fuels burns have been since then. Again, increase in population, great increase in energy use, and also in the materials use. So most plastics, for instance, a great signal, of human activity in sediments. That is post 1950. Most aluminium, of which we now have 500 million tons circulating somewhere around the Earth, is post-1950, and so on. The growth of the megacities is post-1950, and so on. So, and that is also a sort of globalization, which means you start a process somewhere in the Earth, and it very quickly migrates across the rest of the Earth. So we're currently working on, if you like, having a stratigraphical boundary, just as a proposal, this is early days yet, around about the mid-20th century. Perhaps starting with Alamogordo in 1945, if we want a single moment, or perhaps a little later. That is still to be worked on. If we could have the next slide, please. And that's just a slide which shows the great growth in energy use, which has driven a lot of these changes to the Earth. It's just been called the Great Acceleration by Will Stephan, Paul Crutzon, and John McNeill in that. So if we go back to the previous slide, if we could please. Of course, we also have the changes still to come. We have to, we have not yet gone through a large mass extinction event, though it is Probably more likely than not, we will have one in the next few centuries with business as usual. We have not yet shifted temperature, global temperature, significantly. That's likely in decades to centuries, or shifted sea level. So we also have, if you like, the effects of this ongoing phenomenon. And some people have said the beginning of Anthropocene is still in the future. So that is, if you like, a progress report on where we are. And it's an interesting and complicated problem. And all these kinds of phenomena, which have been referred to by my colleagues here, feed into this process.
Thank you very much. We'll now open the floor for questions. Are there any questions from here in the room?
Christina Reed, freelance with Climate Wire. And I was just wondering, Jan, if you could say how in the future, with geological epochs, they come and go.
Yes.
At what point will the Anthropocene go?
Well, I think it depends. I think the comparison is best with one of, let's say, of the perturbations of the past, which has had effects which have worked through the system. And of the effects working through the system, we have physical effects, if you like, the growth of cities, the megacities that Jean described. If humans were to disappear tomorrow, for instance, or next year or next century, that will be an event marker which will not be propagated further. If we're talking about perturbation of the chemical systems, like, let's say, the Paleocene-Eocene thermal maximum 55 million years ago, there was an injection of carbon from the ground into the atmosphere, a global warming fossil acidification event. And these lasted of the order of a few 100,000 years. And so you had dissolution, removal of coral reefs and things like that. And then, of course, we have the biological signals. And the larger the biological, any change now sets the course for the biology of the future. So as the meteorite at the KT boundary killed off the dinosaurs and much else, it cleared, if you like, the Earth for the growth of the new biology, of the Paleogene, Neogene periods, and in fact the modern fauna. So we have a set of phenomena taking place, and how you would, in the far future, as it were, look back and categorize that depends on the relative importance of these different effects as they play through, the physical, the chemical, and the biological effects.
Yes, Randy Shostak, reporter with EOS, the newspaper of the American Geophysical Union. With the term Anthropocene in such wide usage, I'm wondering if you could respond to whether it matters whether this is formalized as a geological period, and why.
Well, I think it does matter. I think because we may have some slight differences of opinion in terms of setting a boundary and how defined that boundary needs to be. But from what Jan and all four of us have said, we live in a geologically and atmospherically and biologically transformed globe. And, for example, the humans move around more sediment now on the Earth's surface than natural processes, rivers, lakes, etc. And therefore, it is not the same as any period that's been in the geological past. So we cannot avoid but study humans as the principal driving agency. And that, to my mind, means that we're in a different geological period of one sort or another. The question as to whether at what rank it should be is actually a more difficult question, as indeed whether we need to define a boundary that, if you like, or how sharp that boundary needs to be. Because, and this is something that I think we ought to raise, which is that our boundaries in the past, it's very different to do this now, because our past geological boundaries are largely set by the dating methods that we have to define them. So, in fact, even the finest boundaries between epochs in the past are no finer than about 3,000 to 4,000 years, because you can use paleomagnetics, you can use an iridium spike in some cases. There are various ways of doing it. But you still would never define a boundary down to a year. That's obviously an impossibility in the geological past. So you can take two opposing views here. You can take the view that a pragmatic view, which is that you need a spike, and that you accept that the globe did not transform between, say, 1949 and 1951, but it's a pragmatic location at which you can put a boundary. Now, that may have various political implications, or you could take I suppose, the polar opposite in terms of boundary setting, which would be to say it's a process which has been diachronic. It's not a sudden boundary in geological terms, and you could say, well, it's basically the period of transformation of the Earth's surface fundamentally by agriculture, because of course it's agriculture that drives industrialization. That's the roots. You have to feed everybody, and you produce industry and urbanism as a result of agriculture, and that's what's transformed also the biological record. The rock record will be transformed by that, but that would be about 3,000 to 4,000 years, and that where you go in that decision-making process has some important knock-on implications too. For example, for the status of the epoch that we traditionally see ourselves living in at the moment, which is technically the Holocene. Since the Anthropocene hasn't been formally ratified, we are still living in the Holocene. But the Holocene is rather an unusual geological epoch. It was defined as basically the end of the last glacial period, and it has an unusual. It's actually formalized in an unusual way as well. So it is important politically as well, if you like, of the small p, as well as practically, I think.
Can I make a comment as well? So towards the second bit, why is it important? There's clearly an academic aspect of sorting it out correctly in a correct historical and scholarly manner. But there's another side to it, which is that essentially, I think as humans, we're still behaving like hunter-gatherers with unlimited resources. When I may say so, I think that's a typically North American approach, that the world is an open barrel and we just have to use it. The question is the boat full? And I think when we're looking at the atmosphere, which is the early warning signal, we're seeing large changes and great modification. With respect to agriculture, agriculture's of course been dominated by the industrial production of fertilizers through the Haber-Bosch process, which is only 100 years ago. We're now feeding 7 times the number of people we were feeding at the Industrial Revolution. So the issue is probably as important that the Anthropocene is recognized in order that we might move towards achieving a sustainable development, where we have to move from this hunter-gatherer, let's go for it, let's use everything. I mean, the oceans are being fished out. On every level, biodiversity is massively being influenced by human behavior. So the question is, are we going to have the evidence base to provide the policymakers with a way forward? And that's where the observational systems are not moving fast enough and quickly enough to provide that unequivocal base. If you believe in it, it's a matter of belief systems, but if you want evidence, we need to show it. So it's really important, I think.
Just as a mind point, I agree with all of that, and I just want one point, if you like, stratigraphically to emphasize that we make the divisions to reflect the great dynasties, and we seem to be in the beginning of a new dynasty. The choosing of the boundary, as Tony said, is quite often pragmatic, and the boundary level itself can be quite trivial compared with the great changes which are around it. And it doesn't minimize any of the great changes. It's simply a marker level that can be traced, can be used to represent a level or a time plane. For instance, the Ordovician Silurian boundary, great perturbations, mass extinction event, large glaciation, large deglaciation, stagnation of the oceans, and all of that. The boundary level is the appearance of a couple of species of planktonic fossil, trivial environmentally compared to that, but useful practically. In that. And it's simply a dividing level, that's all.
Thank you. Are there any other questions? I think we have time for one more, if anyone has. Tim, is there? Oh, sorry, there's one here.
Luis Lidón from the Spanish news agency EFE. I'm not a specialized reporter on science. I would like to know when is going to be taken the decision to recognize or ratify this Anthropocene new geological or not. I mean, if there is any fixed date about that.
There isn't a fixed date. These things in geology work extremely slowly, I'm afraid, almost over geological timescales. Yes, that's right. Yes,
the process of deciding on the boundary may take longer than the boundary itself.
Yes, it may indeed. Yeah, there is. And they literally normally take decades. The quaternary boundary has just been decided, I think, after something like 50 years. The Ordovician took 20 and so on. We've been working since 2009 on a boundary which I think has got more complications and more baggage than any other. We have said, as a working group, in response, I think, to many questions of this sort, we will try and have an interim set of, at least within us, either consensus or statements of a lack of consensus over the questions of should we or shouldn't we formalize it, in our view, over to what hierarchical level, when should it begin, how should it be characterized, by a time or a physical reference. We will try and have that by 2016, I say moving at breakneck speed, I'm afraid, for the next International Geological Congress. But we do not have the decision power. We are right at the bottom of the feeding chain of all of this. We're a working group of a subcommission, of a commission, which in turn has the International Union of Geological Sciences above it. So once we put the evidence down, we hope as a book, putting in the evidence, putting all the various work that's been done together, then that will be taken by the subcommission above us, the Quaternion subcommission. And then they will, how long they will take, I have no idea. They may turn it down flat, or they may decide, let's carry on talking about this, or they may throw it back to us for more evidence. Hard to say.
There is a technical problem here, which has been faced before with, in fact, very, very old boundaries, and then also more recently with the boundary between the ice ages and the present warm period, which is that it's very unlikely that one would be able to find a particular locality somewhere on the globe that one would easily be able to say, this is our type site, this is our type locality. That is the method that's generally used, normally on the basis of fossils, the appearance of particular fossils at a certain location, a certain rock strata. That breaks down in the ancient, right back in the Paleogene, right back in the early Earth history. You can't do that. And it's also not been able to be used for this, the current epoch, in fact, the Holocene. And because of the nature of what has actually been described to you, I think you can see that it would be quite difficult to try to use that precise approach in relation to the Anthropocene. But there is an alternative which is probably going to be used. One of the reasons it's not a good idea is that we've seen long arguments about the relative merits of different sections up some mountains in Austria, for example. I'm thinking of the Lower Jurassic boundary as opposed to a bay in southwest England. And in fact, in the end, it comes down to a process of voting when you actually have a system which is defined using type sections. And that has its problems if you look at it.
Back to politics again, indeed.
And so it probably would be a good idea to try and avoid that kind of, if you like, process of establishing a boundary.
Yeah, I just wanted to follow up on on that. Given that you're going to be making a decision in 2016, I wonder if you could give a sense as to which way the committee is leaning at this point. Is it correct to assume you're leaning toward a definition of Anthropocene?
Okay, we try. I mean, again, it's a rather non-standard working group because it includes both geologists and non-geologists in this, and probably roughly equally balanced. And also, while we're trying to build the concept clearly, we also try and include known critics of the Anthropocene in that. So, this is a concept that needs to be built up, but also needs to have bricks thrown at it to see how it will survive the process as well. I would have said that there's probably a consensus that this is worth formalizing as at least within the group. There is less of a consensus about where it should be, again, because of the, we include archaeologists as well as others. What level? I think we're still we're off the scale in some levels. Other levels, climate, we're still within the Holocene norms, still, though the drivers are well beyond. But epoch is probably a reasonable compromise, and it does have the point to the question is, has the Holocene finished or not?
I just have one quick. I'm chairman of another committee, which is actually a committee which is formed of the British Society of Geomorphologists. So the geomorphologists have set up a separate committee to look at this question, and our consensus is that we certainly do think that it will be and should be formalised, and probably again at the epoch level. What we're struggling with is, if you like, how that will be done, and the whole question as to how and how you set the boundary.
Yeah, we'll be talking more for years.
I'm sorry we have to finish here because there's another press conference coming up. I know there are more questions. You're welcome to approach the panelists afterwards. Thank you very much for the thought-provoking presentations. Thank you all for coming. And the next press conference is in about 10-15 minutes on looking into the past to predict future climate, and we'll present results from IODP and Past for Future programs. Thank you.